Hello and welcome to another video in our discussion of table calculations. We learned a lot about table calculations, and again, they're not just for the sake of calculating, but they are giving you the ability to re-express data. So if you're looking for insights, sometimes raw data, the way it was given to you, and all the metrics that you have might not reveal certain things unless you re-express them in relationship to either that same metric or another metric. So table calculations primarily deal with the same metric, and you're just trying to re-express it. In addition to regular table, we need to talk about bidirectional tables, or just understand the concept of bidirectional table, because the number of dimensions that you're going to display in your table, whether you display them on rows and columns, might influence the way your calculations are working. So we need to talk about the fact that when you have all dimensions either in row or a column, we call those unidirectional tables or table or crosstabs. When we have multiple dimensions in such a way that you have them both in columns and rows, we are talking about bidirectional crosstab or table. We will still use compute using just like we did before in our other examples in previous videos, but now that result might actually change by the fact that we have bidirectional crosstab. So what we're going to do is create a crosstab in Tableau. It's going to look something like this. We're going to have a year and a quarter and gender, and then we'll create a unidirectional table as a crosstab, and then we will change it to bidirectional crosstab, and we will use percent of total. So for that, we actually need to go to Tableau. We're still going to use divi data, and we're going to use 2016 and 17 data. If you watching all these videos in sequence, you already have everything loaded. You don't need to do this what I'm doing right now. That means 10 files, quarterly files plus quarter 2 in 2016 is 30 months, so that will be then 10 files total that we need for 2 years. And we already have April of 2016. I'm just going to grab the other ones. We decided to let's just show it again. There was union. There was this option. Let me just undo it. You go here, convert to union in the drop down, and now allows you to actually grab the remaining file and create a union. If you don't know how unions work, we did it in previous video. You can rewatch it and get comfortable with it. This didn't work. There we go. It says pen. Perfect. We will load them, and we can then go to our sheet, and here we are. So just like in our slide deck, we'll start with creating a bidirectional table. Before we do that, we need to do that calculation. Remember, we had start time and start time, two versions of it. We need to clean up that data. So create calculator field. We'll create a new start time. And if you remember, we had an issue where I think 2016 here for start time was null. So what we will do is if statement, and then if it's null, value found in start time without space or underscores, then select the other start time, which is with underscore. Otherwise, else just use the start time without any space, right? And then okay, that will clean up the data. Valid. We're good. Let's just double check. We'll put it here. It's gonna take a few seconds just because it should be over 7 million records. And there it is, about 30 seconds. Let's just double check that our count. Yeah, it is we look at an analysis total 7 million records. Okay, 7.4. Very good. So this is working. What else do we want to do? I think this is the number of records count. You remember we can do another one. Number of records for each record, a value of 1. We have this option, and we can also do calculate field, number of trips. We can use count trip ID. Just to make sure you can do count distinct, and each trip ID to be a separate one. They're all three same values. Okay, very good. So we wanted to create a view in such a way where we are going to use start time. I will use a year, and we will also use a quarter. Here they are. I can, that's fine if we'll leave total for right now. The important part is that for both year, we have the date part, and quarter, date part. There we go. And if you use number of records, it's fine. Here it is. And what we wanted to do is also use gender to make it bidirectional crosstab. There it is. There we go. We have a couple dimensions here, one dimension here, in rows and columns. This is something that we call bidirectional crosstab. If I move this from columns to rows, we see that we have nothing in columns anymore, and this is unidirectional table crosstab. Okay, so let me just go back here. Let's go back to our deck and make sure. Okay, very good. We will use percent of total to show you how using that computation, how it changes now that we have the option of bidirectional crosstab. So if we change this to be quick table calculation, and we say percent of total, what we are seeing here, that it's actually across, right? So how do we know that? If you first of all, it's selected it says table is across. If you look at edit table calculation, it shows you as well compute using. So what it's doing is simply saying, I'm going to take a look at the whole table. I'm just going to look across now and do the percentage distributions between male, female, and null values for gender, and it does it. Okay, if I were to do table down option, what table now says, okay, I'm going to approach the whole table, and I'm going to do it in such a way where I'm going to look at going down, right? So now we see that we are going to take a look at things for year and quarter, each combination. What percent does that represent for each gender, right? So if you look at for female, look at for male, and then look at for null values within gender, it does that calculation for us. If you select table, shouldn't be surprised, right? It's going to treat the whole table, and it's just going to look at for each combination of gender, quarter, and year, and take a look at that value compared to the total for everything, and then calculate it. Let me just take these percentages off because it's right now confusing. So totals, we will not do any totals. There we go. Pane down. You see what it's doing now? It's kind of similar to table down, but instead it says, wait, we can treat everything as one thing, one big table. We're going to look at separate panes, right? Those separate panes are created by a combination of a gender and a year. So we're going to look at each of these separately, as well as then each of these separately. Okay, and all of them have to add up to 100%. So if you add up these 400%, these 400%, so forth, and then for 2017 the same thing. Now if you take a look at pain, and it actually looks at only the whole year of a start date as a definition essentially of a pane, right? See how it grabs the whole thing. And now when you sum the percentages within that whole pane here, it's going to be 100%. Same for 2017, 100%. Okay, if you do cell, it's just, basically in this sense, it really doesn't, it's not going to do anything. It's just going to say this whole cells represents 100% of that cell. So that's kind of going through our options of tables using bidirectional table and using compute using. Let's see where we are with our deck. We covered all of this. Very good. All right, so the next thing that we want to talk about is calculations using computer using are connected to the way you decided to create that table or that visualization, right? So what is in rows and in columns and how you laid it out, it's actually going to drive what the result will be. As you change that visualization, what's going to get calculated is going to change. Okay, but you already know from before that you can use specific dimension, and then have if you have a good understanding how partitioning and addressing dimensions are associated with each visualization that you're creating, and you know the logic of calculation, you're actually able to then use a calculation in such a way that it's always the same what you're calculating, regardless of what is and how you're displaying it in your visualization. So we are going to, before I go into example, just show you very quickly what that means. So if I select table across, right, take a look at it here, that I could create the same thing if I used specific dimension. Okay, and I'm doing it in such a way where I'm using dimensions that are not checked as my partitioning dimensions. So those are dimensions that I'm grouping by. You can almost think of it, I'm creating some kind of a wall and closing them separately by quarter and year, and then I'm doing calculation across gender. Okay, so in this lingo, that's the addressing dimension. So how you're actually going to calculate or compute the table calculation within each partition. So if you go back here, because quarter and year combo becomes a partition, I'm going to have one for this line, for this line, for this line. I'm going to have 8 of them, right? So there is 8 combinations of quarter and a year, so 8 partitions. And for each one, I'm going to take a look at the total of that partition, and I'm going to say, well, what is the percentage distribution between null, female, and male? And that's my addressing dimension. And that's what Tableau does. Okay, that's the same as table across. Table across does the same thing, but table across depends on the layout for it to work. If you always wanted to calculate it this way, what is partitioning and what is assigning dimension, you can control it this way. Okay, if you go in table down, notice how its equivalent when you use specific dimensions changes as well. So what we are saying here, what we're going to do is we're going to create a partition for each variable value within gender. Okay, so we're going to have 3 of them. Okay, and then what you're going to do is calculate for each year and quarter combination, which are these values, these individual values. Okay, there's 8 of them. What percentage of total of 100% do they represent, the values themselves? That's how that works. And so that's table down. If you wanted to do table, we are essentially, there is no partitioning, but we are calculating a percent of total for every combination of gender, quarter, and a year. So essentially, every cell here, 3 by 8, as a percent of 100. What percent of 100% does it represent? Pane down, we are treating gender and a year as a partition combination. Okay, and then for that each partition, so there's going to be 1, 2, 3, 4, 5, 6 partitions. For each one of them, we are computing, we are calculating the table calculation by understanding a distribution across quarters, because that's assigning dimension. So with quarter one, what percent of total is that? 4.9%, right? So these need to add up to 100%, and then these, and these, and these. Oops, that's I want to keep all. Okay, pane. We are partitioning by year, so we're going to have 2 partitions only. Okay, and we are doing the calculations across gender and quarter. So now we're going to have 3 by 4. So we're going to have 12 values. We're trying to understand for each cell what percentage of total of that partition they represent. So that's that discussion, just making sure you guys are comfortable understanding how partitioning and addressing works. Let's now go to creating another bidirectional cross tab, where we're going to create calculate field called trip type, and we'll add trip type to column. And then you can take a look what happens when you use compute using. It's almost the same, but it's going to change. So what are we going to do? We are going to come up with 3 categories. Oops, I want to do that. So create calculated field, not parameter. Okay, trip type. If trip duration, if you remember that's in seconds, is less than 600 seconds, then call it short. Else if trip duration is less than 1800 seconds, so it's half an hour, 30 minutes, then how did I call this? Medium. Everything else that remains, call it long, and then end it, right? There we go. Have a trip type. And let me just double check what we want to do. We're going to add it to a column. So trip type is right here. Put it to column to the right, not to the left, because it's going to look differently, right? If you do one of these, it changes it. Okay. There it is. And you now see that the calculations are going to be very similar, but not the same, because we added an additional dimension. So if you go into your edit table calculation, you're noticing now that we even have a trip type, right? So now the meaning of a cross might be slightly different in terms of how you would build it if you use specific dimension versus table down, right? So you just kind of need to think about it, what that means. And the best way to do it is just go through each option and do a little, maybe mapping of, if I select table across, try to think about what is partitioning and what is assigning dimension, and see how that works, just to get comfortable with it. And that's it. We can call this bidirectional cross tab. And that's it. Hope you enjoyed it. Let me know if you have any questions.